Andrew and Neil, do you guys mind if I introduce you guys as just like 2468 Team Appreciate? Is that cool?
Yeah, do 2468.
As long as you say 2468, I'm cool with that.
Yeah.
All right.
Thank you all for joining us for the inaugural Texas First Robotics Competition Workshop, hosted by First RGV. A little bit about us, and then we will turn it over to our presenters today. First RGV is a nonprofit founded in 2015 that supports the FIRST community in the Rio Grande Valley, which is an area approximately 3 hours long by 2 hours wide, sits next to the border of Mexico. Yes, in Texas, it's easier to measure by driving hours than miles, just because Texas is just large. Since 2015, we have seen explosive growth of teams in our First LEGO League and First Tech Challenge program, but our growth in the First Robotics Competition program is positive, but we are not where we need to be on ensuring access to the more than 250,000 students in the K through 12 space here in the Valley. With our events like this, we are doing our part to create awareness of our efforts and the need for strong sponsors and mentors to help our community. We are proud Texans, and I'm honored to be part of the First in Texas Robotics Territory. Our organization is proud to be hosting this weekend's event. If we have any technical issues, please remain patient. We will get them resolved as quickly as possible. While you're engaging in the chat, asking questions, and saying hi to your neighboring team, or maybe a team across Texas, we ask that you remain on topic and know that this session is being recorded for teams to take advantage of this great information later. We will post this information on the First RGV YouTube channel, and you can access it directly by visiting youtube.firstrgv.org or by searching for First RGV on YouTube. I want to personally thank the First Robotics competition teams across Texas that have come together this weekend to make this live event possible, and for the hard work of our First senior mentors and AmeriCorps Vistas across Texas that stand ready to help support our teams. On behalf of First RGV, we hope everyone has remained safe during this pandemic, and we are confident that all of the partners across Texas will be getting ready to bring you a robotics season soon. Thank you.
So hello, welcome to the utilizing FRC SolidWorks presentation. This is by team 2468 and team 8053, team Appreciate, and team Rage Against the Machine. My name is Isaac. And joining me are Andrew and Neil from 2468. And we'll be showing y'all a presentation through some basic and some more advanced usages of SolidWorks in FRC. So yeah, and we're going to be taking questions all throughout the presentation. So feel free to ask in YouTube or whatever platform that you're watching this on. And those questions will come to us and we'll try to answer them to the best of our ability. So yeah, we're going to start with utilizing SolidWorks as a new team. So SolidWorks in general, SolidWorks is essential to any FRC team. You need to be able to design and CAD your robot before you do fabrication. And so you can make sure that you keep a track of the list of the parts, that you can make sure that design constraints and stuff all apply, that you're not putting in things that will break other things. And there's just a whole mess of helpful things that it does for you. And that starts at just kind of organizing everything correctly. So using Google Drive, backup and sync, or some kind of synced storage for collaboration to make sure that if you have multiple people CADing at a time and a full design team, that they can all have the correct file revisions, the correct versions of every part that they're working off of, that they can make sure that things are synced when you upload them, or that just everyone's working off the same file so that you don't accidentally overwrite each other, step on each other's toes, etc. When you're kind of CADing and when you're designing parts for the robot, when you're getting in assemblies for the robot, that's another thing. Since SolidWorks works off of having parts and then having assemblies with parts within them, you'll have it so that if you don't have all the parts that are mentioned in an assembly, it'll break and get real mad at you. So all that's really important for having good synced storage. In addition, thoughtful file organization systems. It's really, really easy throughout the midst of an entire FRC season to get completely disorganized and struggle with organizing. Struggle with keeping everything together in one place, it's very difficult to get files so that they are named correctly and are in the correct directories and folders where they should be appropriate, where you're separating parts that you made custom from parts that you downloaded from the internet, making sure they're named in a way that makes it so that they can be used. In addition, getting licenses distributed and installed on design team computers is very important. You got to make sure, one important thing is that each new season, SolidWorks is updated every single year. There's always a new version of SolidWorks with minor revisions and changes that is not backwards compatible with older versions of SolidWorks, or not functionally backwards compatible. And so you need to make sure at the beginning of the season, or even really before the season starts, that you have gotten from your coaches and your mentors the licenses for distributing and downloading SolidWorks. And we're not going to go through downloading SolidWorks in this demo, but it's certainly something I think it's very Googleable. And that's the other important thing, is Googling. The internet is your best friend. Cannot tell you how many times I've had a problem with this software and I just look it up, and there are many, many forums out there, many, many helpful people. SolidWorks has an official forum. You can ask on Chief Delphi. There's, I believe, the FRC Discord. There's a lot of really good resources that you can reach out to that can help you with weird problems that might not have been covered, or you might not have run into. Weird features popping up, settings that they have turned on by default that might break things, errors you don't understand. It happens all the time. SolidWorks is a massive, massive program, and it's very, very powerful, but also very, very complex. And so it's really, really good to be able to demo, or to be able to Google and to be able to just, figure out what you've done wrong and how to fix that, how to solve that. And we're going to go over some of this stuff. We'll have some demos later on through the presentation, where we're going to go through and do some basic CAD and show off some more advanced features like templates and a lot of cool stuff.
So this is the 2468 file structure, or otherwise named naming convention. So during season, we break down the robot into each of the subsystems that we think you're going to need to have at the beginning of season, right? So here you can see the first thing we have is basic architecture. That's where we did a volumetric of the robot, so we could figure out where all the subsystems need to go. And then past that, we just have a folder for each subsystem. And in each of these folders, for example, the hang folder, we have each time we redo the hang. So the hang went through 6 iterations, all the way A through F. And in each of these folders, we have each part. So we always name it with the team and then the year. So A for appreciate, 20 for 2020. And then the version, so basically which folder it's in. So this is from the example E, and then the part number. So part 0, we always make the derived part. We'll go over more what a derived part is later. Part 1 is always the main assembly for that subassembly. So you see we have all of our parts there going all the way to 16. They usually go to a lot higher than that. I think you're muted, Isaac.
Sorry about that. SolidWorks has, for SolidWorks Basics, there's a lot of terminology that SolidWorks has that is not immediately like apparent to someone who's not used to CAD and not used to SolidWorks. And so I was going to do about here a demo of our, I'm going to show off 2 things. Firstly, the CAD of our robot, 8053's the machine. And after that, I'm going to show off that is kind of a large robot assembly. We can show off sort of parts of that, what the features are, how we've made things. And then in addition, this is kind of the next side, but also for COTS parts, so COTS stands for commercial off the shelf. And there are parts that you would buy, like a Versa gearbox or some, Versa frame or something like that. And I'm going to go over how to download those parts, how to import them into SolidWorks, and how to use them in assembly, as well as for the basics. I'm going to do a little demo of just showing off kind of what these are, what all these terms mean, and how to do just a very, very basic CAD that most of you will probably have to do at some point in your season. So I'm going to just go ahead and do that. So let's open up SolidWorks, shall we? So here we have wonderful, wonderful, wonderful SolidWorks 2019. And we're just going to make a brand new part here. So let's go open a new part. And we're greeted with our lovely gray screen. So the first thing you always want to do is you want to create a sketch when you're making a part. Now, SolidWorks kind of works off of a system of sketches and then kind of extrusions / features based on those sketches. So you make a 2D drawing, then that 2D drawing becomes a 3D shape, and then that 3D shape can be modified in different ways so that it's, so you can get all the different features you want. So let's start by sketching out. So we're going to sketch out a piece of Versa frame, some 2x1 extrusion. So that's, your 2x1 aluminum bar. So we're going to start by making a rectangle, center rectangle right here in the middle, placing it at the origin, making sure that stuff is centered around the origin. Make a second one here. Another very important SolidWorks term is dimensioning. So a dimension, a smart dimension. Oh, I'm sorry, my units are not being happy with me. Dimensions kind of allow you to make sure that things are measured properly and those measurements won't change. So for instance, it's a 1x2 piece of extrusion, so it's going to be an inch tall. Oh, let's fix this middle one. This guy's a little too big. And we're going to make it over here. It's long. Now, if you notice, these parts became black once I did them, when I dimensioned them. That means that those parts are defined. So if I try to move these around, they won't actually move back and forth, unlike the blue parts, which are undefined. This is just SolidWorks' way of knowing that it has fixed dimensions. You can set dimensions in this box down on the left. However, those won't stay if you change, for instance, another thing in the assembly. And so you want to always make sure when you're CADing for just clean robot CAD that you want to be smart dimensioning a lot of stuff. You don't want to over-define things, but you do want to make sure that the dimensions here hold and that you don't end up accidentally changing parameters that you don't want changed. The last thing I'm going to do here is I'm going to set this is going to be our wall height. And I'm going to make that an 1/8 of an inch. Do an 1/8. Do it on that side. And another neat little thing we can do is I use a lot of relations where you can, if you hold Control while you click. So I'm gonna click this. I'm gonna click this. I'll get this add relations bar on the side. Relations are basically different relations between geometry that can help you define what you want things in accordance to other things without having to do math yourself. It's essentially just SolidWorks doing geometry for you. So I could just define this other side as 1/8 and be done with it, and then I'd have a fully defined sketch. Or what I could do is, because I have these helpful little center lines here, and I know that if I want them to be like this, if I want my wall height to be the same, I could have them, or no, that wouldn't work. I'm sorry. I could here, just give me 1 second. Sorry about that. I was just talking about relations can help you just relate to parts of geometry in a way that makes it so that they will work for you. So if we go ahead and do these collinear, those lines will always match up. And that didn't quite come out the way I wanted it to come out because this is a rectangle. I realized that. But you can use them to define some things. So we are going to just do 2/8. I'm sorry about that. Another 1/8 here. But for instance, if we didn't have these center lines, if we were just sketching out boxes or whatever, and we wanted these to be always like this, we could set this line and this line to be parallel, for instance. And we don't need to do that because it would over-define the sketch. It's completely unnecessary here. But you can use that. It's very, very helpful for making it so you don't have so many of these smart dimensions lying around, but you also have a lot of, clearly defined geometry. So this is basically our sketch. We're sketching the front profile of this. So if you had a piece of aluminum 2x1 extrusion, this would be the very front. So imagine you're looking down the tube straight down. And this would be the 2D profile of that. So what we'd want to do is we'd want to pull this out and extrude it to make it, for instance, to make it really our actual aluminum extrusion. So it's a part. So we have the sketch tab here. This is for mostly sketch tools. And then we have features. And there's a lot of features in SolidWorks, but the one you'll probably use more than any other one is the extruded boss base feature. So that makes it so that it will take your sketch and it will extrude it outwards. So it will basically make it into like a block that comes out. So it automatically selected this for me, but it selected this contour here. So this box selected because it detected that automatically. If I wanted to, it could do the middle box, but we don't need it to do that. And we're just going to go here. Let's call it 6 inches. So we have a 6-inch bar right here. That looks pretty good. So that defines our length. We're going to do blind. This is used for relations to other geometry. But for now, we're just going to do blind, which means it doesn't care about anything else in front of it or behind it or whatever. It's just going to go completely blind forward. So do that. And ta-da, we have our little 2x1. Though I did say that I wanted to make this VersaFrame, which if you don't know, VersaFrame has, in the side of it, it's got holes evenly spaced at 1-inch increments. And those can be used for mounting gussets, which Versa also makes. So I'm going to show off, just for this, I'm going to show off another cool feature that you'll probably use a lot, which is called patterning. So we're going to start a new sketch, and we're going to do a completely new feature. Except this sketch is going to go on the side of here because that's where the holes generally are. 1, 2, 3, 4, and they're holes that cut all the way through. So we're going to sketch on this side. Another handy trick, if you hit the space bar, you can pull up this little block thing, and it will let you actually select which face you want to have looking at. So you can perfectly straightly align your part. So VersaFrame uses holes, so obviously. And so what we're going to do is I'm going to sketch a circle. SolidWorks also has this neat little feature where it will tell you exactly the middle point of this. Like that. Make a hole. Check. Now this hole is blue. It's not defined, but I do want to define it. So let's go from this to the edge. Let's make that distance 1/2 inch. Generally, that's how you'd want to cut it if you had real life VersaFrame here. So we'll do 1/2 inch. It's already kind of, see how it's up and down. What we can actually do is I believe we can make it so that this and this are, no. If we want to make it so that it's fixed right in here, one thing we can do is we can go and make a center line. Push that center line to right there. And that'll make it so that this guy does not want to move. The only thing about this that's variable is the holes. So we have that going for us. Now, the one thing I would like to, one thing that's important is that we need to make sure we have the right holes. So we can actually, this is a very Googleable thing. Yeah, so you can look up a lot of these features will have. So here, I'm going to switch my screen real quick to Google Chrome one more time. So if you'll see, so the VEX website has a lot of really good resources. Aside from CAD files just for these actual parts, if you wanted them, there are certain reasons that you would want to not download these parts. While they're helpful to have, you can do a lot more with your own parts often. But the thing that they do have that's very, very nice is drawings. So this drawing, I think I can open up here. Yeah. These drawings will let us determine just some dimensions about this. So, you know, what these distances are, that's 1/2 inch, 1/2 inch there. There's a 1/2 inch distance there. Typically, there's a 1 inch there. It tells us the wall length. I made a little bit of a thicker wall, but that's okay. We can change that if we need to. It's 0.04. So we'll change that when we get back into the CAD. And then it tells us how big the holes are. So it's 0.163, which I'm guessing is 0.1625 because it's an eighth, I believe. So these drawings are super, super helpful because they can make sure that you actually, when you're CADing a part, and a lot of manufacturers that don't provide CAD files almost always will have a drawing that you can find and you can base off of. And you just read this. It looks just like it's SolidWorks. It probably was done in SolidWorks because SolidWorks lets you generate these drawings. But it gives you kind of, oh yeah, so I can double check what the holes are, what these distances are, what my design constraints are, how this all just works. So if we are to go back into SolidWorks, we can go and firstly, we can set these correctly. So you can smart dimension this circle. And we could say we want it to be 0.1625. There we go. And that hole is now defined. Sorry, I'm moving around a lot. And then the cool thing, so we want these holes. Now, what we could do is we could manually CAD a hole every inch down the entire length of our thing. Though that would be completely impractical because it would just mean that we'd have way too many there would be way too many dimensions. There'd be way too much geometry. And in general, when you're making something that will have a lot of moving parts in a really, really big assembly, you want to try and CAD efficiently if possible, so that you're not rendering too much and you're not putting too much strain on your computer. Because when you get into those really, really big robot CADs, those can put a strain on your computer really, 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 really bad. So we want to CAD, and it just comes down to like tiny, tiny little optimizations. But one thing we're going to do is we're going to do a linear sketch pattern. So we'll select this here, and if you see, it made a little copy. So basically what a linear sketch pattern does is it will take whatever feature you have, sketch feature, say the circle, and it will copy it linearly. So it can copy it down a line, it can copy it up and down, left, right, or it can even make a grid if you need. But right now we're going to just use it to make a line of evenly spaced, exactly the same copies of this hole. So we've got the spacing between them. So because the drawing said we wanted them an inch, we do them an inch between it right here. And then for instances, we're going to put 5 down. No, we can do 6. This is a 6-inch bar. 6 of these. As you can see, it's going to make 1, 2, 3, 4, 5, 6. It's going to make all of those. Here's where you select your entity pattern. If I wanted to pattern it in the other way, I could do this, and this lets me flip direction. But for now, we're just going to do it this way. And you press check, and look at that. We've got all our circles that are exactly the same, all put in there, all nice. So our last thing we want to do is we want to cut these out. So in SolidWorks, just like there's an extruded boss base, so an extruded kind of pull out, there's also a negative one, which is the extruded cut. So basically, this will work exactly the same as the other one, but it's subtractive instead of additive. So what I just did, as you can see, it's taken these guys and it's cut them. Now this is set to blind still, if you'll remember. So that means it's going to go forward 6 inches and cut all 6 of this inches, or all 4 or whatever inches there are back here. We don't really need that. We just want it to slice the whole thing. So we can select through all. And that just means it'll cut through anything in its path. Anything that is there will be sliced in this little hole pattern. So you just select that through all. And if we go cut, ta-da, we've got all our holes, all spaced super evenly. And it's almost all up to code. Actually, what we can do is if we want to modify. So for instance, we got this wall thickness wrong. It was 0.040 inches in the drawing, but we made it like 1/8 of an inch. And you can find some extrusion, but if we're doing VersaFrame, let's make it stick to the dimension they want. So to fix this, what we can do is we have on our left tab, we have every feature we've done. We can click this little arrow below and access the sketch, edit the sketch. And what we can do here is we can just go to these smart dimensions. This is what's so nifty about these, is because we didn't get this dimension right, what we can do is we can just change it. So we can go 0.040, like that. And then we fix this one as well, 0.0. And look at that. Now our thing is square again. And then these are the correct dimensions. So if we exit the sketch, SolidWorks will automatically update so that our VersaFrame is perfect. So there we go. And this is our very nifty little VersaFrame. And we'll go over some advanced features so you can, later in this presentation, so you can optimize this even better. And so you can use, again, this was just a very quick kind of dirty into CAD if you're a super, super beginner. But we'll go over some other things if this is not new to you, over like how you can make a template so that you don't have to CAD this every single time, or that you can make it so that this is just a variety of different optimizations built into SolidWorks that you can use. The other thing I wanted to show off though, so let's go save this part as, so I'll just go and save it into my CAD folder real quick. FRC. Let's put it in here and we'll just call it Versa frame 2x1. Just right there. This is not really a proper naming convention, but it's just there. But you, of course, won't CAD every single part you find in your robot. You will have a lot of different parts in your robot that you don't CAD, and maybe even most of them. In the example of my team's robot. So let me open up the CAD for so I'm going to close out of that for now. Not that. Please open up. Let me go. Oh no, I need to find it again. Hold on a second. Sorry about this. But we are going to just look at the CAD, a completed robot CAD. So if y'all can see this, this here is our yeah. So this is so we're just gonna suppress all missing components here. Oh yeah, sorry if I wasn't looking at the chat. Sorry if I missed zooming in the drawings. Oh, SolidWorks is being unhappy. Here we have a complete robot CAD. So right here, I'm gonna just sketch this, set this like this. So here is what our finished robot CAD looks like. So we've got all sorts of nifty things here. As you can tell, these are 2x1 extrusions. We have a lot of parts in this robot. However, we did not CAD every one of these parts ourselves. We have a lot of parts in here that are definitely not ours. So for instance, this motor with a 775 Connect, this red line, we didn't CAD this by hand. We downloaded that part off the internet. Same with these sprockets and these. Now you could CAD every part by hand, but that's not a good idea, because you want to make sure that everything is exactly up to manufacturer spec. And if you mess up and it's different in your CAD than it is in real life, then you could run into all sorts of terrible design constraints or terrible, design issues. So we've downloaded a lot of parts here. Even this 1x1 channel, these gussets here, and I'm actually going to show off how we can download a gusset and affix it in an assembly to our nifty little Versa frame that we just made. Here's the Vex tubing, which is similar to Versa frame. Yeah, or a battery, for instance. There's a lot of things in here that we didn't CAD, that we couldn't have CAD'd, just because we want to make sure it's up to exactly manufacturer specification. So so here's our quick little demo of our robot. We've got our shooter, our intake. We don't generally CAD electronics, though you can. It's just a lot of things. You might want to CAD just big bodies for electronics to just make sure that you can know where they all rest and whatever. And there will be parts of your CAD. Your CAD it can be, but our CAD isn't truly encompassing of what our robot looks like, but it is almost every major feature. So for instance, we don't CAD every single little bolt, or every single little, no, sorry, not bolt, nut, for instance, that's affixing these two. But you certainly can, and you should when possible. So we have rivets in here, and you should, whenever possible, big bolts and nuts like this. We do have, but yeah, so you just use this. This is our robot CAD. We use this as our robot looks almost exactly like this. And you, of course, use this. This is a month of work on CADing, a lot of nights working on this. So yeah, so let's go over, let me do the quick little download demo. So we can close out of this, don't save. I wanted to do a demo. Let me screen share back to Google again. And sorry, this wasn't zoomed in on here, but I can zoom in these drawings a little bit if you want to look closer. We've got our holes, we've got our dimensions here. And as you can see, these are laid out just like SolidWorks dimensions, very conveniently. Wall, it tells you exactly what these are. Wall, inch, it gives you a metric, whatever. So I'm going to just do this very quickly. We're going to go to gussets and mounts. So I've already pulled up this tab here of our different gussets for mounting things. But we are going to mount, we're going to download this little 90-degree gusset here. So something you should know when you download these is SolidWorks works off of solid parts. And we don't actually have, most manufacturers, not most, but a lot of manufacturers, including Vex, who you'll get a lot from, don't actually give you a solid part, which has all SolidWorks features. They'll give you what's called a step file. So let's go download this 90-degree gusset. We'll download a little zip file. We open this up, we get a step file. Extract it real quick. There's our something-step. So so we've downloaded that. Oh, you guys might not be able to see my library windows. Hold on. If I show off just my whole screen, share this. All right. Yeah, we download this, extract it, and we get this step file here. What we're going to want to do, we're going to want to open up SolidWorks, open, and SolidWorks can open step files. However, it goes through a little bit of a diagnostic when it does it. So I think it was, let me just double check. It was 3551. Yeah, sorry. I was doing some demos earlier just to make sure this is all tested. So let's go ahead and open up this thing. So we'll load in the model. We can run import diagnostics just to make sure that nothing here is breaking SolidWorks. So it says, okay, it's fine. And we get this. Now this is a solid body, which basically means that it doesn't have a lot of features. So remember on our last part, it had a bunch of features. This is just one solid body here. We can still work with this. It just means we can't, for instance, change the size of these holes or something, which you probably won't need to do all that much, or you can do in different ways. But right now, we're just going to show how we can mate this and do a very basic assembly with this to the frame we just made. So what we can do is SolidWorks works off of, I talked earlier about terminology, but we have parts, which are individual little individual components. And then you have assemblies, which is multiple parts all put together. So what we can do here is we can go new and we can make assembly from part. There's also drawings, which is like what we looked at with the first one. We can save this file, save and insert. Let's just call it this -step for now. Normally you'd want to label this like the naming structures we went over. We can just go, we can select that and we can place it in here. Now we are in an assembly. It doesn't look very different, but it is an assembly. Our bar is different. And so what we have up here is we have insert components. What we can do is we can browse documents. And if you'll remember earlier, we just stored in here, we have FRC, VersaFrame 2x1. We can open this guy up and we can toss it in here. So now we've got both our parts in this assembly. So these are multiple parts. We can't really edit these. We can kind of edit them if you need to on the fly, though in general, you would probably want to just open up the part and edit it in there. But we want to mate these two together, which means we basically want to simulate what it would look like if they were joined together in real life. So to do that, we have, oh, this one's fixed. I'm sorry. Is it fixed? Give me a second. Float, yes. Float is the opposite of fixed. So we want this just to float for now. So what we're going to do is we're going to hit the mate tool. We're going to select the faces we want to mate. So it already had this one selected, so we can just work with that. Let's select this face. We go mate. These are coincident. So that means that these two faces will always want to be in that kind of plane of each other. And with this, basically, that's how you'll do mates. What you want to do is, for instance, now if we want to mate, let's say we want to do this face here and this face here. And SolidWorks will pop it in there. And look at that. We have, oh no, see, this went the wrong way. So what we need to do, we need to go into this, look at our mates. That was our mate. So we can go and edit this mate here, and we can just flip the alignment. It's always so much fun to watch him move around. Now, we can hopefully see. I am not sure I quite did this right. Hold on. Hold on a minute. Sorry about that. Yes, delete that. Let's do first. Oh, wait. That wasn't correct either. I deleted the wrong one. Let's go ahead and mate these again. So we're going to do this face to this face here, like that. That's oriented correctly. And let's do the holes next. So what we can do is we can mate the outside of this hole right there and say this one. Yep. Those edges are together now. And so in real life, you would probably put some rivets or something, but those are, I believe, fully defined together. They're not going to move. But yeah, so that's how you'd want to put that in there. So as you can see, these parts overlap here. In real life, you would bolt these together with some rivets or bolts or something. But yeah, that gives us our kind of mate here. So yeah, that's kind of a basic rundown of just SolidWorks. I'm not going to say this, of SolidWorks features and kind of how we can use those features to just do very, very basic robot CAD. So I'll hand it over to Andrew and Neil for the next section.
All right, so since Isaac just went over the basics of SolidWorks, you can get a lot more complex. For example, if we're doing a full robot CAD, I don't think we're going to be doing like CADing individual 2x1s, for example. So even though that's a valid way to do it, it's just a lot easier if, for example, you have templates already pre-done. So can you guys see my screen? All right. All right, so I'm going to start a new file here. Then you're going to see I already have a bunch of pre-made templates. These are all different templates for, like, for example, 2x1, 1x1 channel. So the way I set this up is we can send the link of our presentation in the messages, and we have a linked folder to our files for the templates. So how you set that up, you save the file somewhere, and then this isn't going to pop up automatically. You're going to want to go to Settings, and then go here to File Locations. And then you're going to have to see, I set where my file location was for templates. So it's automatically going to pick up where my templates are. So then it will give you, when you click New, all your templates. So it's a lot faster. So if I open this 2x1, for example, it's just going to be like a 4-inch 2x1 by default. But the thing is, with templates, you can change however long you want it. So for example, if I needed 6-inch 2x1, and I click OK, it's going to update, and then I'm going to have a 6-inch 2x1. And then you can just save this. It'll save as a part file and just save it wherever you want. So that'll save you a lot of time, and you can do this, for example, 2x1, axle, spacers, basically whatever you want. So also a cool thing with templates is you can actually make them. So for example, if I start a new just basic part, and if I wanted to, for example, if you guys needed like a custom hex spacer and like we didn't have it in our folder, or you just didn't download our folder, you can easily make one. So if you just go here, make yourself a hexagon, and then what do you need? Like 1/2-inch axle spacer. So then just make another circle for your wall. Then smart to mention this, have like a 10th wall. Yeah, should be good. And then here, when you click extrude, you're going to want to set this. We're going to go over a lot more complicated variables later in the presentation, but this is just simple. So you just put an equal sign, and then you just put whatever you want your variable to be. For like X, for example, it's just going to create a global variable, then click OK. And then notice how I set my boss extrude to 0.10 here. So then we can go up here to our equations, just click it, and then you're going to see we have the same thing as the other templates here. We can change this to example 1 inch. It's going to update when I click OK. Now you have a 1 inch. So the tricky thing with making these is when you save them, you have to save them as not a SolidWorks file, but you have to save them as a part.dot file. So then that will be your template. And then save it to your templates folder, wherever you set it to, and then you should be good. All right, I think that's gonna wrap up this half of our presentation. We will see you guys at 11.
Okay, thank you for that. And that closes out this session. And we will see you back promptly at 11 for the next session.
This concludes this session. If you're watching us live, please take the time to go back to YouTube and pick up our next session, or you can always visit our live page at firstrgv.me/live and pick up the next session there. We appreciate you watching and participating in today's session.